Hey class, I wanted to make a quick video, it's only be a couple minutes, to explain something that I kind of skipped over in 6.3. For 6.3, the method of Frobenius, the question is, this is our guess. So we're going to guess, our solution looks like this. It has that unknown r that we'll find out in the middle of the problem. The index starts at 0 and Cn x to the n plus r. So I guess the question that I didn't really answer is, if this is our guess, why is it true that our derivative looks like this. N plus R Cn x to the n plus r minus 1. That's kind of pretty self-explanatory. It's just the power rule. This power comes down and you subtract by 1. But I guess the question is, why is it still at 0? And same thing for the second derivative. It also starts at 0, and it's just the power rule again. So the big question I want to answer is, why are we starting at 0? And why not starting at a different place? Like last in 6.2, when we're doing regular power series method, we went to 1 in the derivative, and went starting at 2 in the second derivative. So let me show you why. So here's why. Start with your guess of y is equal to, starting at 0, Cn x to the n plus r. Let me write out what that looks like. That looks like C naught x to the 0 plus r plus C1 x to the r plus 1 plus C naught C2 x squared plus plus r. Let me erase that. See, I jumped the gun. So it's actually going to be x to the r plus 2 and so forth. C3 x to the r plus 3 plus C4, boom, explosive, like that. So let me take its derivative. So y prime would be, take the derivative of all that, and what would we get? So if I take the derivative of this first one is, C naught x to the r. So if I take its derivative, it's going to be C naught x to the r comes down, C naught x to the r minus 1. And then the next one is going to be r plus 1 times C1 x to the r plus 1 minus 1. And so forth. This next one will be r plus 2. Again, just doing the power rule. Like that. So you see that even on this first one, this is the n equals 0 term, and this is the n equals 1 term, and this is the n equals 2 term, that we have a value here. For n equals 0, it's r times C naught times x to the r minus 1. This is meaningful. It actually has something that's going to play for us in the power series. R minus x to the r minus 1, that's, some polynomial or whatever, or some x to some power. So that's why when we write out the series here, I see that the formula looks like it would be, and this is like, the n equals 1 is matching, the n equals 2 is matching. So it looks like it's n plus r. And then looks like the n matches here, here, and here. So it's going to be times Cn. And then looks like it's going to be x to the n plus r minus 1, just from the power rule. But I am starting at 0 and going from there. Ooh. So that is why, that's why we start at 0. That's why we still start at 0. Yep. At n equals 0 in the index. All right, and it's the same reason for, and similarly for y double prime. Okay, let me do a different color. So I hope that helps, and hope you are enjoying the method of Frobenius. Our home dog, Frobro, he's very fun, and we're having great fun with these problems. All right, thanks. Bye.